Okay, here we go. So, I'm asking you to find the sine ratio, cosine ratio, tangent ratio. Will you remind me of the little mnemonic we have that helps us remember that? So, Toa, which I really like writing this way because you can see the ratios a little bit better. Okay? So, SOHCAHTOA. And in order to figure out those sine ratios, what do we need to do first?
You gotta find the side.
Find that third side there, which we can do what? Pythagorean theorem. Yeah, so 6 squared plus b squared equals 10 squared. What does b turn out to be?
8. Oh, it's 8.
It's 8. I heard 3, 4, 5. Tell me what 3, 4, 5 means.
It's like it's a smaller triangle.
Yeah. So 3, 4, 5 is what we call a Pythagorean triple. And so you can see if I can write this a little differently. 6 is 2 times 3. 8 is 2 times 4. And 10 is 2 times 5. And so this is what we call a scalar multiple of a 3, 4, 5 triangle. So every side has just been multiplied by 2 to get those new larger sized triangles. And so 3, 4, 5 is a Pythagorean triple, which means they always form a right triangle. Do you know any other Pythagorean triples?
Yes. You mean the radical 2? Oh, there was one with a radical in it.
Well, 1 radical 2 is true. 1 radical 3, 2. So these are special triangles. They're not. I wouldn't call them Pythagorean triples just because they're not integers. But there's 1 radical 2. You know any more like that are integers?
2, 4, 6. I don't know. 12, 16, 20. Yeah, it would still be 3, 4, 5.
5, 12, 13 is a triple. 5, 12, 13. There's also 7, 24, 25 is another good Pythagorean triple. Yeah. All right, you don't really need to know those though, as long as you know the Pythagorean theorem and can apply it, you're fine. All right, so this is what is the sine ratio looking from angle B right here? Opposite over hypotenuse, which would be
6
over 10, which reduces to 3 over 5. The cosine ratio looking from angle B is adjacent over hypotenuse, which would be 8 over 10 and reduces to 4 over 5. Good. And tangent, according to angle B, is opposite over adjacent.
6 over 8.
6 over 8, which reduces to 3 over 4. All right. Very good. Here we go. So we are applying that same knowledge today with our SOHCAHTOAs. And so we have a triangle. It is a right triangle. So know that is a right triangle. Important.
Let's put some further.
All right. So we have this side length x. We have this angle of 60 degrees. We have this side of 32 inches. What we want to do to solve for x is say, hey, what do we know? If I'm looking from this angle, what label can I attach to this side? Opposite. And that makes this the adjacent. So if I have information about the opposite and adjacent side, which trig function can I write? Tangent of my 60-degree angle equals opposite over adjacent. And now it's just a matter of solving. So what should I do to get? Yeah, cross multiply. Or I'm just going to multiply the x over here. So x times the tangent of 60 degrees equals 32. And then how do you get x by itself? Yeah, divide by the tangent of 60 on both sides. All right, and so then that's what we get to plug into our calculators. So let me ask you, what mode should your calculator be in? Radians or degrees?
Degrees.
Degrees. Why degrees? Because they gave us degrees. That's exactly right.
Oh my god.
Degrees.
Wait, so if it's that's what that means? I never knew what that meant. Oh my god.
All other times it's radians. If they give you degrees, it needs to be degree mode. So you go to mode. Go to mode and change it to degrees.
What if I'm a Casio user?
You have a degree button, and I can show you where that is.
Deal.
All right, so then you just get to type in 32 divided by the tangent of 60.
Yeah.
Let me think.
The fraction is so ugly.
Option 4.
Yeah, I thought that was right.
What was that?
It's already there. 32 divided by. All right, what'd you get for x? 18.47. Units? Inches. Oh, so that should probably be 18.48 inches. Right.
Yeah, I still didn't get it.
It just affects. It's just you like that.
Divided by the tangent. Option.
Oh my god,
And so you can see it's still there now. All right, from a lighthouse deck, 80 feet. More. All right, from a lighthouse deck, 80 feet above the water. From a lighthouse deck, 80 feet above the water. Ooh. That's a guy. All right, he's on his lighthouse deck. He is 80 feet above the water. A capsized boat is observed. So we got a boat in the water. That's capsized. And he's saying, ah.
Ah, that's me.
Okay. I've been capsized before. Always exciting.
Really?
It's
It's capsized as well, actually.
It's like becoming capsized. That's kind of capsized.
All right.
You've tipped over in a boat before. That's literally my biggest fear. Oh my god.
It's fine.
It happens a lot when you're canoeing. Okay. All right. The funnest one was being capsized on our Hobie Cat, which was, do you know what a Hobie Cat is?
No.
It's a personal like sailboat. So
Oh.
it's a little Hobie Cat, and it's a sailboat, but you
Shake.
and then you just fly through the air because it just like launches you over. That was real fun.
That's so scary. Water is terrible.
Just because they can't ever get blood. It's like it's all.
I just don't want to
Measure
do
30
30
seconds.
seconds.
Those are tight. All right, so here's what we want to learn right now. This is the really important part. A capsized boat this is going to be on your test. You better listen. Is observed at an angle of depression of 5 degrees. When we're talking about angles of depression or angles of elevation, we are talking about line of sight, because when we're normally looking and walking around, we're looking straight ahead, right?
Yeah.
Okay. And so it's important that this guy up here on the lighthouse deck is looking, normally he's looking straight out horizontally. But he has an angle of depression, which means he's got to look down from horizontal 5 degrees down, and then he sees this guy in the boat that's sinking. Okay? This is an angle of depression. When we talk about angles of depression and angle of elevation, we have to reference line of sight, meaning the horizontal. Angle of elevation of 30 degrees looks like this. If I'm looking straight ahead, then I have to elevate 30 degrees. There is my angle of elevation of 30 degrees from horizontal. Does that make sense to you? They always have to be from horizontal. Yes.
So for the 5 degrees, would it be in the top corner or would it be in the bottom?
So this is 5 degrees, but you're asking about this corner?
Wouldn't you be able to figure out that?
So first of all, this lighthouse, we're going to assume safely that it is perpendicular. Standing straight up, this is not a leaning tower of Pisa. All right. Ladies and gentlemen, what's this angle measure? 85. Very good. How did you know it was 85?
Because 90 is looking straight and then you put down.
Okay. So this was a right angle before, and we had a little 5% of it. If this is 85, what's this angle down here?
5. Wait, I don't know. Don't. Yeah, it's 5.
It's 5.
Yeah.
Yeah, there you go.
Why?
Because it's opposite from the 5 degrees.
Wait.
Is it? Equals 180 and then 85.
So 85 plus 5 plus 90.
Is it? Yeah, that's what
Very good, very
I
good.
said.
We have here, ladies and gentlemen, parallel lines,
Yeah,
sort
that's
of.
it.
All right, this is the test. We have parallel lines,
Yes.
and if you have parallel lines cut by a transversal,
Opposite.
alternate interior angles are congruent. All right, you remember that stuff? Those are very important. Did you need that? Not necessarily right now, but we will need it later. So it's important to remember those parallel lines are very, very useful. Okay. All right. So now I have an 85-degree angle right here. That's very important. We want to know how far is the boat from the base of the lighthouse. So we want to find this distance, X, right here. How far is the boat from the base of the lighthouse? Yeah, so looking from my 85-degree angle, then I have my opposite side is X. And what would the 80 feet be called? Adjacent. And so opposite and adjacent is the tangent function. Tangent of our 85-degree angle is opposite over adjacent. How do you solve for X?
Cross multiply.
Cross multiply. Multiply by 80. 80 times the tangent of 85 degrees is X. So I'm just going to plug that in. 80 times the tangent of 85.
That's big.
914.4 feet away.
Okay.
No, in a real life situation.
Yeah, that boy David.
You can actually. It's called an inclinometer. It's pretty easy to make. I was gonna do it. I need more time to make up all these projects. I really want to.
Make a garage.
You can make an inclinometer. It's really easy. All right. Do you guys have any questions? Yeah.